Question 4. When substances P and Q react together to form substance R, an equilibrium is established according to an equation. Equilibrium constant expressions Kc equals R squared over PQ square brackets. Remember Kc square brackets. 1.0 moles of P and 1.0 moles of Q are mixed in a container with volume 1.0 dm cube at equilibrium. X moles of P had reacted. The amount of moles of each of P and Q at equilibrium is 1 minus X. Deduce in terms of X the amount of moles of R in an equilibrium mixture. So use the ICE method. ICE, initial moles, changing moles, equilibrium moles. We've got P, Q and R. The only difficult thing about this question is using algebra. So 1 mole of P, 1 mole of Q. Equilibrium X mole of P had been reached. Therefore, how do we go from 1 to X? Well, it's going to be 1 minus X, because 1 minus X plus 1 will give us X. Same thing for Q, it's going to be 1 minus X. And it tells us that in the question, amount of moles of each of P and Q at equilibrium is 1 minus X. For R, well, it doesn't give us the initial moles of R, so we're going to assume it's 0. And instead of doing, so therefore it's going to be 0, and instead of minusing X, this is on the opposite side, this is on the left hand side, this is on the right hand side, R is on the right hand side. So instead of minusing X, we're going to add X, but because it's got 2 moles and that's 1 mole, it's going to be plus 2X, so we're going to get 2X, and therefore we get 2X as the amount of moles of R in the equilibrium mixture. Pretty tricky 1 marker. 4.2, at 298 Kelvin, the volume equilibrium constant Kc is 3.6. So first things first, let me no, we can leave it like that. So we get 3.6 is equal to R squared, 2X squared. Now obviously you could show equilibrium moles divided by moles of concentration and volume. Concentration is moles divided by volume, which volume is 1. So 2X divided by 1 squared over 1 minus X divided by 1 times by 1 minus X divided by 1. We've got 1 minus X. Sorry, that should be 1 minus X and 1 minus X. No, we shouldn't. That's X. Yeah, so it's going to be 1 minus X squared yeah, because it's going to be 1 minus X, because these two become squared. Ones will cancel out, so we get 3.6 equals 2X squared over 1 minus X squared. And now we can square root both sides. So we get root 3.6 equals 2X over 1 minus X, because the root will just get rid of the square terms. Therefore we get times that by 1 minus X, we get root 3.6 bracket 1 minus X equals 2X. Therefore we get root 3.6 minus root 3.6 X equals 2X. Get root 3.6 equals 2 plus root 3.6. Can be like 3.89 7x, x is going to be root 3.6 divided by my answer. I'm going to save my calculator. I get x is equal to 0.49 mole per dm minus cube. However, R, from the beginning, we know we've got 2 moles of R, so therefore to find the equilibrium concentration of R, we're going to do x times by 2. So we're going to do 0.49 times by 2, which will give me 0.97 mole per dm minus cube. And that's the end of question 4.